fully customized sensors integrated into ETOS. In one of my earlier videos, I explained to you the basics of our Sensorbus function in ETOS and how easy it is to add a pre-configured sensor. But what if the sensor that you want to integrate is not yet known to Reinhausen? You will see that thanks to our Sensorbus function, this is not a challenge at all. Today I want to show you how to do this. So there are technically a few things we need to have ready at our hands, to have prepared, to be able to begin with the work. So apparently the custom sensor is needed. It should be wired up and connected to a stable power supply so that we can actually do the integration and prove the communication in the next step. A manual for that sensor would also be very great to have, apparently for the Modbus port, for the supply voltage, and for all the terminals that we're going to need and to know where to connect it. Modbus data point list, which I have here on my laptop computer, is also crucial to carry out the work. A wiring of the Modbus signal is also needed. We recommend a daisy chain wiring if we have more than one sensor, go from first to second to third and onwards. Lastly, the software for the sensor is needed. So the initial configuration of the sensor, the initial address that might be adjusted or that might need adjustment, and the interface settings. So in our case, the 19200 8-even-1 for the Modbus communication. Now with these things sorted, we can actually start to add the sensor here from scratch into ETOS. So on my laptop, I have here the visualization of ETOS on the right side and the Modbus register map on the left side. So I want to go to settings and to the sensor bus here. And now, as you know, in the sensor editor, we're going to go in there and we want to add a new sensor. Click add new sensor. And now I want to add the TFMR, because that's technically the sensor we're adding, and in brackets Peter, so that we know this is the version we're using. Reinhausen Inc. For example, it doesn't matter, you're fully free to add whatever you want to add in there. Also the version, you can flexibly set the version. So if you get a newer version of a sensor, you have another sensor with the older version, you can determine the differences. Pressing accept takes us on to the next page. Now we're actually going to add the Modbus register, the data points. So to know which data point we want to add, we need to know which type of Modbus signal we're going to be receiving. So apparently here we're using analog information like a temperature and the humidity in oil value. So therefore the sensor provides us a float 32 or a signed integer value. So I want to start with the float 32, and the value is being presented in a read input register, so IREG. I have the IREG selected here. As you can see, we have several others that we can choose from: the holding register, discrete input, and coil, but IREG is the correct one. Pressing new brings me on to the next page. Here I can now enter the actual data point. So in my case, I want to start with the water in oil, or humidity in oil, in parts per million. The data type of the register is a float 32, F32, and now my register number is the actual register number. But be aware that many manuals present that as a decimal value, and the actual register address is by default presented in Modbus as a hexadecimal value. So if I would now convert that 3EA hex value into a decimal number, I would receive 1002 as the correct data point. That's a bit speciality about Modbus that you need to be aware. Little endian for the word order is what I need to select here. Lastly, a multiplier. I don't need a multiplier because the float in my case does not use any scaling and any multiplier for the value as it transmits the value directly. Pressing accept adds me this data point, and I want to use the second one, the temperature in degrees Celsius. Same case here, a float 32 as a little endian data point, which is the Modbus standard. And now my register number for the temperature in degrees Celsius is then going to be, I made a mistake here, that's going to be the 1002. And I need to modify the humidity, which is, I jumped a line here, the 1140. And once again, so you see if I double select the value, the system tells me I made a mistake. Degrees Celsius, float 32 and 1002. And the little, come on, little endian, press accept. And now I created that 2 data points. Pressing accept activates that default, that new sensor preset. It's crucial to understand that in the editor, I'm creating a kind of a, sensor sample that in the next step, I can actually connect logically to my ETOS if I go into the sensor management. In here, I press new sensor, and that sensor now has the address of 19. And if I go all the way down in the list, I can find my TFMR Peter here. I can select the version. I cannot check the assigned functions as I can always do with the pre-configured sensors. But for this one, ETOS simply doesn't know yet where to connect the data points logically that are being transmitted from the sensor. Last step, pressing accept. And now the system tells me you need to carry out a reboot. Now, the last thing we can do before we actually carry out the reboot is to link that function further in our system. I want to go to Sensorbus and the function assignment. And here I can find a relative water content for my transformer. I can link that to the humidity in parts per million and oil temperature, well, in that case from the DGA sensor, it doesn't matter. We're going to use that value just to show you how the linking is done here. If this is done, now I can safely carry out the reboot on my system. So the reboot is done. Now let's take a quick look if our integration worked out properly. I want to go to information, and here under system I can find Sensorbus, and well, we can see the blue icon showing me that the TFMR Peter was successfully integrated. And we can also see that we have a humidity value and a temperature value. So apparently humidity is about 25 ppm in the room, and the temperature is also about 25 degrees Celsius. So integration was successful, as you can see. If you prepare the wiring properly, then the physical integration of Modbus data points is really not a big deal. One last thing before we close that video for now is, well, if you figure out that the sensor is not working and you need to modify it, the modification is done essentially also here in the sensor editor. You can click the little gearbox, jump in and click edit, and now we could actually modify the data points that we added. Then by pressing OK, we're going to store that new sample for the sensor, that new updated version. Now, if in that point, it's really important that to actually make it work, we have to delete the sensor at this point here again. And, well, unit asks for reboot. We want to add the newly updated sample once again from the list and add it once again, carry out the linking, the function assignment once again at this point. And once this is done, we can carry out another reboot and we can prove that our updated values have taken effect here. Good. So much for the integration of the sensor. Thanks for watching. See you again soon.